Okay, this is going to be a short little video about data cables, just so you're aware of them. Now, if you've been working in IT for, if you work in IT, then and you work at a data center, you're gonna know this. So you're not gonna even you can. This doesn't apply to you, but for say for example, you're starting a home lab, or you're you're in school. You'll learn this too, but just a refresher, a reminder of what's out there and what it's for. So we're basically going to just talk about twisted pair. So right now we're going to talk about category 5E, category 6, and category 8. So twisted pair data cables history. In 2001, category 5E came out. In 2002, category 6 came out. And then in 2016, category 8 became available. Now, just some acronyms, so you know, I'm not making it up. There's some people they're gifted with gab. They can talk much, but then if you ask, if you push a little, try to get deeper, all of a sudden, they're like, they heard it from someone else. They didn't what do you call it? They didn't have any classes, or they didn't get trained. They're just here and there. I'm not saying you have to have classes to know this, but it's just good to know where some of these things came from. Like good acronyms to know is the TIA and the EIA and ANSI. EIA it doesn't even exist anymore. So TIA, Telecommunications Industry Association. And there's the website there. I'm going to put this will be in the description as well, in case you want to look them up. Telecommunications Industry Association is accredited by the American National Institute to develop voluntary, consensus-based industry standards for a wide variety of information and communication technology products, and currently represents nearly 400 companies. So there's the wiki there. The EIA, Electronic Industries Alliance, they define standards for telecommunications cabling systems. EIA agreed to develop a set of standards and formed the TR42 committee with 9 subcommittees to perform the work. The work continues to be maintained by TR42 within the TIA. EIA no longer exists, hence EIA has been removed from the name. And then we have the American National Standards Institute. It's a private non-profit organization that oversees the development of voluntary consensus standards for products, services, processes, systems, and personnel in the United States. The organization also coordinates U.S. standards with the international standards so that American products can be used worldwide. Now, this is just something to know about these cablings. The ANSI TIA 568 published 2020 replaced TIA EIA 568D of 2015, Revision C of 2009, Revision B of 2001, and Revision A of 1995. Now, the wiring standard, TIA 5, EIA 56B, I don't know why I still put that, 2001, uses a straight-through wiring method for twisted pair cabling. Now, can you see my, oh, you can't see the mouse. And you don't see this slide. Oh, there it is. what was I saying? The wiring standard, it uses straight through. So what a balanced twisted pair, let me go ahead and read it. The standard defines the pin assignments for 100 ohm balanced twisted pair cabling, likely category 5E and category 6 pairing. The wires are connected in pairs with pins 1 and 2 forming one pair, 3 and 6 the second pair, 4 and 5 the third, pin 7 through 8 the fourth. And these are the assignments: white, green, white, orange, blue, white, blue, orange, and white, brown, brown. Now, the one I always use when I'm crimping my own cables is the orange, white, orange, white, orange. I should have just wrote it the way I speak it. Orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. Now, what you need to understand here, data flow, Ethernet communications uses 1 and 2 to send, 3 and 6 to receive. Okay, so 1 and 2 to send, and then 3 and 6 to receive. 1, 2, 3, 3, 4, 5, 6 to receive. The rest is just for noise reduction. You can look that up, but it's 1 and 2, 3, and 1 and 2 to send, 3 and 6 to receive. I've seen people, they just take a, I'll do a diagram of this later, but they just see the Ethernet port, and then they just plug in a Cat 6 from, they're like, yeah, it's just an Ethernet port. I can plug in my laptop to the other laptop, and it should communicate. No, it should not. You need a crossover cable. But a little on that later. So you just needed to know just know that 1 and 2 to send, 3 and 6 to receive. Now, this is the old 2001 category 5 cable. In this, the 5E was introduced and ratified around 2001 as an enhanced version of Cat 5, designed to support gigabit Ethernet speeds, 1000 base T, and reduce crosstalk, quickly becoming the standard for home and business networks through the 2000s and 2010s. The release year is 2001. The key improvement, the E stands for enhanced, offering better performance and enabling 1 gigabit per second speeds, a significant upgrade from standard Cat 5. Standardization, the Telecommunications Industry Association formalized the standard, making it prevalent for new installations. Now, its adoption, its ability to handle faster speeds, and its backward compatibility with older Cat 5 systems led to its widespread adoption, replacing Cat 5 rapidly. Now, what came next is Category 6. Cat 6 was developed and officially ratified as a standard in 2002, offering significant performance improvement over Cat 5e with better crosstalk reduction, noise, and higher frequency support up to 250 megahertz for faster speeds, though it became truly popular a few years later as networks demanded more bandwidth. The release year is 2002. Performance allowed for 1 gigabit per second speeds over longer distances around 55 meters, 100 feet, and can support up to 10 gigabits per second for shorter run. Now, I wouldn't promise you that. Say, for example, you're plugging into you have a 1 gig switch, plugging into a 10 gig switch. I wouldn't use Category 6. Now, these Category 6s, it has a central spleen, a cross divider to separate the 4 twisted pair, to to separate four twisted copper pairs, reducing crosstalk and interference. While available in 2002, it gained wider adoption in the mid to late 2000s as networks needed faster speeds, eventually becoming a minimum standard for new installations. Now, the Cat 6 is great. Say, for example, in your home lab, your demarcation point where your ISP's router comes in, it goes to it from the router, it goes to your personal router, and then from your personal router it goes to a switch, and then your distribution switch. And say, for example, hey, I have an Xbox in my living room, and no, I don't want to go wireless. So basically, you're going to cable up your house. You want to make a home run. And I have a switch next to my Xbox and also to my TV. This is what I would get. I'll buy one of the. I do have one of these, and I did make that type of home run. I did make that type of cabling to my TV in the living room that also has the Xbox. And I'm happy with it. But understand, your switches dictate the speed. This is just the pipe. So I'm just making sure that the pipe, the cable, will do its job. Now let's talk about Category 8. Now this is the ones that came out in 2016. Category 8 Ethernet cable was officially released and ratified by ANSI TIA Standards Committee in 2016, becoming the newest standard for high-speed data centers, supporting speeds up to 40 gigabits per second over short distances, up to 30 meters, 98 feet, with frequencies up to 2,000 megahertz. Again, the release year is in 2016. Specified under ANSI TIA 568C.2-1 standard. The performance, it supports speeds up to 25 to 40 gigabits per second. But remember, these are operates at frequency of up to 2,000 megahertz. But now here's the application, primarily designed for short-run data center applications. This is the one you need to know. The maximum 30 meters, 98 feet, rather than typical home networks. But I do have this. It's rather an overkill because the router that goes into my home has the speed is 2.5. I have fiber. And it goes to the router provides a 2.5 gigabits per second speed. So from that router, from the ISP's router, I use Cat 8 to plug into my router. However, my router at home is it's a 1 gig, so maybe it's overkill, but for me, just knowing that I'm going to make a diagram of this later. But for me, just knowing that the Cat 8 is there, it gives me the warm and fuzzies. I feel happy about it. I'm like, all right. And also, my desktop has a 10 gig NIC plugging into a 10 gig switch, where the other thing that's there is another is a test server, but I use from that server I use another cable. Let me split that out. Now let's go to the next slide. Now this is more like product placement. Data cables part 2. Gonna talk about the 10G Tech. That's a product. 10 gig base. F SRSFP plus LC transceivers. And then I'm going to talk about fiber, and I'm going to talk about these SFP cables, and then I'm going to talk about another transceiver. So, okay, the 10G Tech 10 gig base SRFP plus LC transceiver. SFP means small form factor pluggable. LC, lucent connector. GBE, gigabit Ethernet. Now this won't make sense, but this is for fiber. This will plug into a switch. So you can read, these are actually product placements. I'll just read it. 10G base SRSFP plus to LC optical 10 gigabit Ethernet fiber transceiver module, 10 gigabit Ethernet multimode SFP plus, compatible with both 62.5 UM and 50 UM LC cables. Supports OM1, OM2, OM3, OM4 fiber cables, duplex LC connector, 850 nm, DDM up to 300 meters. Again, understand your distance. Say for example, I really dislike this. Say for example, again, see now, not maybe you're trying to do it at home, but your telecommunications closet or your telecommunications room where the DMARC enters, where the ISP router sits there. Say for example, you put it in a closet, or you put it in a faraway place, but your main rack of servers is in another room. I don't know why people do this, but I've seen it happen. So what you're going to connect, you're going to make that 10 gig connection to the other switch with fiber, because maybe it's 15 feet away or 30 feet away, and this will guarantee that 10 gig connection. Oh, I'm sorry. Let's go on to the easy installation, plug and play, fully hot pluggable with ESD protection, widely used. Oh, I didn't talk about the compatibility. Compatibility with Cisco, SFP, 10 gig, 10G, SR, Meraki, Ubiquiti. That's what I have. Fortinet, MikroTik, Netgear, D-Link, Supermicro. I also, at work, we have Supermicros, TP-Links, and other open switches. Easy installation, plug and play, fully hot pluggable with ESD protection, widely used in network switch, server, or NIC with SFP to a 10 gigabit fiber channel network with multi-mode for network attached storage area network SAN, and high performance computing, HPC. That's just the transceiver. Let's go now to what plugs into the transceiver. There's your fiber. OM3. This is a product. LC to LC, 20 meters, 65 feet. Multi-mode fiber patch cable options, 7 inches to 50 feet. Duplex 5125 40 GLSZH. Now this is straight up copied from the Amazon, so you can read that. I'll provide a link to this, so just to know it's out there. No, I'll just talk about the usage OEM3 MMF is preferred fiber specification for 10G Ethernet connections. OM3 LC to LC multimode duplex fiber patch cords is especially designed for connecting 10 gig SR, 40 gig BIDI SR, etc., etc., etc. Transmission distance. Now the thing is, remember, it's the distance. You don't. It's always unfortunate. What sometimes you have to do it, but the unfortunate thing is you want servers and you want racks of servers immediately next to the other racks of servers. You don't. It's inconvenient to stick one well. Okay, I'm talking about now home and small office. I'm not talking about data centers, because in data centers you don't play that game. You line up racks next to racks next to racks, and the distance is, you want to make it as short as possible. But if you do have to home run, if you do have to, say for example, do a 20 feet home run, you're gonna go with fiber. Now let's go to the next slide. I'll provide a link in the description for this product. Now these copper cables. This is, you're going switch to switch with these. I'm just showing that it's available, and basically in your switch you're gonna have a port, basically a 10 gig port, where, because you don't want to try to go switch to switch with just a regular 1 gig port, because say for in this one company I worked in back in 2010, I don't know, maybe the person who set up the network just wasn't network savvy, but he just uplinked it. He combined the switches just using a 1 gig port. On the 1 gig port, he didn't use the back option where it provided at that time, the switches that they purchased. They had a special cable which provided a 6 gig connection. But as soon as one user started processing, everything would just shut down. Even though switches are guaranteed for 1 gig a port, it just shut everything down. No one could, everyone, the people in the company would, hey, what's going on with the network? And then I'm like, okay, this is happening way too much. Whenever someone submits a job, everyone gets shut out. So basically, I upgraded the uplinks and to the 6 gig copper basically. And then it solved the problem. But that was back in again 2010 for the equipment that they purchased. But yeah, these SFP plus cables, these are when you're going switch to switch, and there's a little port for it. But again, that's the extensive application 10 gigabit SFP plus cable, widely used in various devices such as a fiber switch, storage, router, server, firewall, NIC, media converter, data center, and other fiber optic equipment with SFP ports. You'll know the SFP port on your switch when you see it. Let's go to the next slide. Now here's the high fiber 10 gigabit SFP plus RJ45 transceiver, 10 G base T SFP plus Ethernet module supports 10 gig, 5 gig, 2.5, 1, and 1.25 gig, compatible with Cisco SFP 10GTS, Ubiquiti, Unify, D-Link, Meraki, Microtech, Supermicro, and more. I'm using D-Link for my... Anyway, I'm sorry. Let's just stick with this. Basically, this would... If you have a 10 gig switch, I do have a 10 gig D-Link. And basically, I would stick... Because they only have SFP ports. And I use this to plug in to the 10 gig, and I use a Cat 8 cable to plug in here. And then the Cat 8 is plugging into my 10 gig port in my desktop. And that's how I'm going through, that's how I'm utilizing the 10 gig switch that goes to my server. Okay, basically, let's go down here to the SFP transceiver. Instantly use without any configuration. Support hot pluggable, plug and play, widely used in switches, server, routers, NIC, media converters, and other fiber optic equipment with 10G SFP ports. And basically that's it. Now this is just to show what's out there. Maybe I'll make another another video with the diagrams of connections to show how, and also pictures of its practical applications. I hope you found this helpful. The links to these products will be in the description. They are Amazon affiliated links. All right, thank you very much.